Hello?
No.
Hello, Mr. Eric, Mr. Ryan, are you alright? Yeah? Okay, so today we're going to find the minimum difference, absolute difference in an array. Okay, so let's say mean difference. Mean ABS. What's ABS? Difference of two numbers.
ABS is absolute.
Two numbers in an array, okay? So let's say 3, 4, 100, 20, 30. If we are about to pick two numbers, what's the minimum difference?
Three and 4.
Yeah, the minimum difference. Minimum absolute difference, yeah? 1, okay. Okay, so now, if I have another one here, which is the 19, okay? So you need to tell me that the minimum difference is 3, 4, and then it's a pair increasing. And another one, 19, 20. 19, 20. Right? So you need to tell me, okay, the answer is that. Okay, so
30, 100.
yeah, so find the minimum, yeah, find the minimum pair of numbers that have the absolute difference, which is the smallest, and then we output the pair in the ascending order. Okay? Yeah? And then one number can only be used, it can be used twice, I think, right? Look, if I have another 21 here, right? If I have another 120 here, you need to tell me, okay, another 121. Okay. So look, even the 20 appears only once, right? Even the appear once, we still need to output it. Yeah? Make sense? Okay, so this task, right? What's your approach? What's your idea? I mean, sorting. Okay, but brute forcing and sorting. Okay, good idea. So, but to do this, we need to separate into two steps, right? First of all, what? First of all, find the minimum difference, which is 1. Yeah. First of all, you need to tell me, okay, it's 1. The minimum difference is 1. Yeah.
What if there's like two does this count like there's 2 notes the same and the minimum difference is 0?
That's a good question. Yes, obviously. If they're duplicate numbers, like the difference is, you find a duplicate number, right? Yeah. Okay. So first of all, we find the minimum difference, and then we go through the array again, and we output the pair. Okay. So for this one, how do we? You said brute force. You said sorting. Okay. For the brute forcing, they are n elements in an array. What's brute forcing? What's the term complexity? For
n squared.
Oh, n squared. Yes. Look, what's brute forcing? For I, okay, for I in range n. For j, yeah. So for I in range n, right? For j in range, yeah, range up to I, right? And then we have a pair ji, right? Then we just have to say, okay, if we first of all we find the minimum difference. Okay, the difference, let's say at the beginning, the biggest number we can think of is infinity, mass dot infinity. Then we can say
I can think of a bigger number, infinity and 1.
Infinity is it's not a concrete number.
It's a concept.
It's a concept, yeah.
Yeah, that's what I said.
It's this thing. Infinity, yeah? Infinity. So there's actually no beyond the infinity, because infinity is not a concrete number. It's like, so big that you cannot even locate it, right? Okay.
Right.
For I in range n, for j in range I, and then this difference, yeah, mean difference equals mean difference. Okay, so the absolute difference, we use the ABS, yeah? ABS, nums I minus nums j, right? What's ABS function? I talk about this all the time. Yeah? And then now I got the mean difference. Look, this is n, that's O(n) squared, right? Okay, what's ABS? Come on, you tell.
ABS is absolute
value. Okay, when x is bigger than 0, it's x. When x is smaller than 0, what does it return?
Returns absolute value.
This is 0. What's x? This is x. When x
Return
is
also minus
Yeah, and 1x is 0 equals 0. Okay, it's just the distance to the 0. Okay.
yeah.
Yeah, absolute value.
Yeah.
So this is O n squared. Yeah? And we sort it. If we sort it, how do we do it? Look, if we sort it, look, we sort this number, so the mean difference would be in what? If I sort this number, what's after sorting? Yeah, this is ARR. If I do this ARR dot for, what's the time complexity? What's the time complexity for this one? Everyone, what's the time complexity for this one? Oh, okay.
Yeah.
Okay, so if I sort this number, that will become what? 3, 4, 20, 30. Eric. After sorting, it will be 19, 20, 21.
22, 23.
No, 100. Okay, so now, if I sort it, how can I get the minimum difference? Where are they? The minimum difference.
Minimum difference is.
Look, if I sort it, so why do we sort the arrays?
Because when they're close to each other, they're the most near to each other, and the other numbers are just.
We're done. Why we sort it? Because sorted, then we can just calculate this difference. That would be the closest, right? There's no point to calculate the difference, right? Let's look. That difference 16. It's certainly smaller than or bigger than these two, right? So I just have to calculate this difference, right? In O(n) time, right? Yeah. So I can just do this diff equal. Okay, again minimum infinity, yeah. And I can do this for I in range, well, 1 to n, right? N is the length of the array, and then look diff equals mean diff what nums I what nums I here. I start from here and do what? Eric, can you complete the list?
I and
Nums I and what should we do?
-1.
Yeah, minus nums I minus 1. Yeah. Okay. Look, sorting O(n) log n. This one O(n). So overall the time complexity is what? Come on.
O to n.
Come on.
O n and n log n.
This is O(n) log n, and then I need to do another O again. So the time complexity is
O to
O(n)
n.
log n plus n, but we drop the smaller part, so we O(n) log n. This is yeah.
Yeah, so that's what we said.
Yeah, okay. Ryan, you said O to n. Why was O to n? O(n) log n plus O(n), right?
Yeah,
So
but you said it's that.
okay,
Didn't you?
look. This equation, two parts. First of all, I sort this one. Second of all, I go through this linear time. Yeah. So if I put it together, it's O(n) log n plus n. But O(n) log n is bigger than O(n), right? Yeah. So we keep the most dominating part, which is O(n) log n. So we drop this constant. Okay. So once we got this difference, now we need to go through this array again, right? Yeah, go through this array again. And then if the difference is equals to the mean difference, I add it, right? Look, after this, the difference will be equals to 1, right? Equals to 1. And I go through this. Okay, Eric, the difference is 1. Okay, so I put the array 3, 4. This one? No. This one? Yeah? So 19, 20. This one? Yes or no?
Yes.
20, 21.
No.
Okay, and then no. Okay, got it. So actually, it's O(n) log n plus n. Yeah. O log n plus 2n. We drop this smaller part. Yeah, make sense. Yeah. Which one is better? O(n) log n. The second approach. First approach is O(n) squared.
Log n.
Yeah. The first one again, because we get the difference O(n) squared, and we need to go through the same process again, and then to check if the difference, if the difference between any pair is the smallest difference, then we append it to the result, right? Make sense? Yeah. So this one is clearly the better. Yeah. Yeah. There's a huge difference. Yeah. If the n goes very large. Yeah. O(n) squared could be like that. Yeah. And then O(n) log n could be like that, yeah? You see? Yeah? Yeah? Actually, no. This is O log n. O(n) log n is this is O(n). O(n) log n is somewhere here. Yeah, because it's bigger than ON, right?
Yeah.
It's bigger than ON but smaller than ON square, right? Yeah, this is N square. This is ON log N. This is N, right? ON is this, yeah? Make sense? ON. When N is 100. This is 100. It's a triangle, yeah? It's a, what do you call this triangle? This side equals this side. This is the right angle.
Rectangle triangle.
Right angle triangle.
I don't know.
You know what I mean, yeah? This is the right angle, 90 degree, and then this side is equal to this side. Yeah? So if this side equals this side, what's the degree here? Okay, one question. You probably don't know, right?
What?
Okay. So if this side equals this side is 90 degree. What's the degree of here?
What?
Come on. This is mathematics, geometry. What's this three angle? Like A plus B plus C. What's this? How much angle is this? The angle of the triangle, internal angle.
3.
Sorry? No. This is 90 degree.
Yeah.
How much is the triangle? Any triangle. What's the triangle? What's the
180.
180? Yeah, we're done. Okay.
45.
We're done. 45. You know how do you get a 45? This is this is 90 degree, right? So A plus B equals 90 degree, right? Yeah. But because AC equals BC, what does it mean? It means these two angles are equal, right? Yeah. So these two angles equal. You can say 2A equals 90. So A equals 45. Of course, B equals 45. Eh? That's how we get it. Yeah. Okay. Make sense? Yeah. Okay. That's it for today. Good job. Bye bye.